Okay, I think it's time to start. Hello everyone, my name is Piotr Przybył. I employ myself as remote freelance software gardener, and today I have a pleasure to show you my presentation about context, CONTEXTVS. This is of course a clear reference to Bill Clinton's campaign from 1992, if you happen to be as old as I am to remember that. When I say ancient Rome, what comes to your mind? Any ideas? Slavery, hunger, what else? Nothing? Great, so hopefully I'll make some references during this talk. Agenda for today. First I'll show you some real-world examples, then it will be a few points about IT world dilemmas, and at the end I'll show you how to determine the context. But before we start, a little disclaimer. Who knows an application or a Latin phrase, caveat emptor? One guy, great. Do you know what that means? Not really. Okay, so I'll explain. So it's a term from ancient Latin law, which is also present in some law systems today. So caveat emptor means that when there's a transaction, there's a seller and a buyer, and caveat emptor means let the buyer beware. So if you are buying a house, it's your responsibility in the United States to take care if there's everything okay with the house. It's not the seller's responsibility. So caveat emptor, let the buyer beware. Caveat auditores, let the auditorium beware. Okay, we're in a very nice basement, difficult to escape from, so I want to play a game with you and all of you. Let's play a little game. In this very situation, which car can go first? Louder. Blue one. Okay, why blue one? Because the red one has give way sign. So the priority is with the blue one, of course. In this situation, who can go first? Red one. Why red one? Yes, exactly, because according to the Vienna Convention on Road Traffic, if the traffic is going right side of the road, the car which has, let's say, right hand free can go first. In this situation, the same crossroads, the same car colors, which car can go first? Anyone? Who wants to play the game? In a basement. Blue, you said blue. Who says red? That guy says red, okay. Who says that there's another option? But doesn't really matter. This is the crossroads. You know, this one is going from this side. This one goes. Let's assume they're going straight ahead. The answer is it depends. It depends which country we're in. In the United Kingdom, for example, if there's no traffic lights, if there's no road signs, there's no priority. They have to agree with each other who can go first. In Australia, for instance, the privilege is still with the right hand. So for a quarter of the world's traffic, it depends who can go first in this situation, which means that context exists. When the car is traveling on the right side, there's context. When the car is traveling on the left side, there's also another context. A context has to be found out. You have to go and find this context. You just can't guess it. You can't infer it. You can't imply, okay, so if we have right side privilege, then they have left side privilege. It doesn't work this way. Context cannot be computed, evaluated. Context can only be found. All right, 169. Is that far? Is that far? Is that not that far? Sorry? It depends, yeah. It depends on what? Sorry, you need to be a bit louder. It's kilometers. Is this far? In space? is this far? 169 kilometers. You say it's not far. Okay. So there was a mission. It was called Mars Climate Orbiter, and it was sent from the Earth, of course, to Mars. And the orbiter was supposed to go on Mars orbit, start orbiting and measure Mars climate in September, and it was September 23rd, and it was like late 90s, and they wanted the orbiter to go this way, this trajectory, 226 kilometers. The safe margin was 80 kilometers above the planet's surface, because Mars doesn't have as dense atmosphere as Earth, but still there is some atmosphere. Apparently, the probe went under this safe limit. After that, the investigation showed it was 57 kilometers above the surface, so there was too much stress from the atmosphere. The orbiter most probably disintegrated, so we lost the signal. There was no radio contact. The mission was complete failure. Why did that happen? Because NASA signed a contract with Lockheed that they will communicate, computers and sensors in a Système International measurement units. So for thrust, they were using newtons, but the Lockheed engineers were using pounds. That's why one computer said a number, let's say 12, another one received number 12, but this one was talking in pounds, and this one was talking in newtons. And because of this discrepancy, they didn't calculate the trajectory correctly, and a probe worth, the whole mission was worth like $330 million at the time. And it disintegrated in the atmosphere. And this, as far as I know, is the only picture took by this orbiter, by this probe, 2 weeks before approaching the planet. So I believe this is the most expensive picture mankind ever took. 330 million, and this dot here is Mars. All right. So skipping the context can be expensive, of course. Sometimes very much. Sometimes $330 million. How fast the light travels? Answers, please. 300,000 kilometers per second. Someone said, well, more or less like that. In vacuum, in Earth's atmosphere, it's on average 90 meters per second less. Please note we are using Système International here, so metric units. Not miles, not yards, not feet. But in diamonds, due to refraction, it's more than 2 times slower. So when I ask you how fast light travels, the next question should be, what is the, is it a vacuum, is it a glass, is it air, is it water, what is it? What's the refraction? And so we can calculate the actual speed of light. So this might not be important if we are sending like Indians, Native Americans light signals. It doesn't really matter. But if you work in a fiber cable optics, this really matters. So make sure your mantra matches your context. So when you say 300,000 kilometers per second, make sure that this mantra matches the context you're asked about. Next, we're sticking to the space travel and so on. This is Columbia Shuttle. It's a starting platform in Cape Canaveral, Florida, United States. And if you don't see that very well, maybe I can zoom it in. Let me see. Yep. So this here is a huge bomb. Well, actually, it's an external fuel tank for the shuttle. And these here are smaller bombs, which are solid fuel boosters. So these are like first stage rockets to take the shuttle up, or they were used to take the shuttle up. And what's interesting in this picture is that some people are wondering why these aren't bigger. You see, the external fuel tank used by the shuttle is so huge, and these are relatively small. The answer is that they are propelled by solid state fuel. This is not liquid, so you can't assemble it on site. These are built in Rocket City in Utah, and then they are traveling to Florida by train. And one of the important factors of trains is a thing called structure gauge. More or less, it looks like this tunnel. So this is the maximum width and height of a train. So you can't have a bigger payload than the structure gauge. That's why these boosters are of this size. They can't get bigger. Okay, but why is the tunnel and the structure gauge of this size? Why isn't it bigger? Well, the legend says that it's because the guys who started to build a railway system in the United States came from London. And, well, this picture is from Lisbon, but it illustrates the idea. You can't have the tracks too wide because two trains need to pass each other. And the streets in the city of London are quite narrow. Why are they that narrow? So the tracks are 4.5 feet wide. Well, the legend says it's because of the Roman chariots. That Romans had a law which meant that two double-horse chariots, need to pass each other on a street. That's why there was a certain width of the street. That's why there was a certain width of tram tracks and then train tracks. Most probably this is a legend, but still it suits the motto that sometimes you can't alter your context because it can live for millennia, and this can be very, very long. So if you are like going to conquer the stars or at least the moon, sometimes the width of horse bottom can determine your context. Next example. This is about office space, like open space. Well, this picture was taken in Moscow, and this is not exactly the open space I would like to tell you about. Imagine something else. I've heard that twice actually. It might be a urban story, but still it serves pretty much for this presentation. Imagine a big hall, maybe something like this, and desks in rows, one another, and computers standing on these desks like two decades ago, and data entry clerks, people who were just taking paper forms, and they were typing the data from these forms into computers. And this was in some kind of Uzbekistan or in the Far East. So brilliant engineers from so-called Western civilization decided that they can use a great feature of PCs, of the data entry clerks, which was the PC speaker. You know, the little buzzer or device that makes like a beep beep in your computer, basically. And the idea was, data entry clerks aren't very, they're not typing as fast as you are. So we can, type the code in JavaScript, for instance, with left hand and sip your coffee with your right hand. They were entering data more like this, finger by finger, finger by finger. This was a very long and tedious and error-prone process. And they were like, moving their eyes on the screen, on the keyboard, on the form, on the screen, on the keyboard, on the form. So it took very, very, very long. So the engineers from Western world decided that they could simplify this process so that when the data entry clerks make a mistake, the computer will tell them, literally, it will beep. Suddenly, it turned out that the efficiency of these people dropped. And this is where the urban stories differ in their message. One says it dropped by 30%, another says it dropped by 40%. Why did that happen? A feature was supposed to make the whole process faster, and it made it slower. Why is that? Well, it turned out that the engineers skipped a thing or aspect of the culture of these people. In Far East, elders have ultimate respect from the youth. No matter what they do, you always respect to them. You always respect your boss, no matter if they say some rubbish or if they make sense. Of course, inside you may know that they said something terribly stupid, but on the outside, you always show respect. And now, if you're entering this data and you made a mistake previously, nobody around you knew about that. Only you knew that. And now with this PC speaker, when you made a mistake and your computer beeped, everyone around knew you made a mistake. So they were still respecting you outside, but in the inside, in their souls and minds, they knew you made a mistake. That's why people, instead of relying on this PC speaker, started to check their input even more to make sure nobody knows they made a mistake. Another example, there was an attack. It's believed it was made by some, let's say, cyber forces of Russian Federation against the government of the United States. And at the end, there was a kind of a denial dementi, if you will. So everyone believed that this was made by a group of Russian hackers, but the Russian hackers wanted to make an impression that this was like the whole attack was made by a single guy, terribly clever. And it was made in a way that the guy just wrote a denial. Thing is that he didn't write it this way. Like, if you see it written this way, like hello, exclamation mark, space, colon, dash, and round bracket, you see that this was written by someone from the United States, United Kingdom, Poland, if you will. This looks typical. But it was written more like this way. If you happen to work with a Russian keyboard, you know that semicolon is difficult to reach. That's why for this emoticon, they're using simply 3 round brackets. And if you write hello exclamation mark in these 3 round brackets, and you do it not only once, but every time, it's quite obvious that you pretend to be English or speaking English, but your keyboard is Russian. And that's why, because of this denial, people said that it was like one more way to prove that it was actually Russians standing behind this attack. By the way, if you receive something like this, like there's a space in the front of every exclamation mark, it means it was written by a guy from France or someone speaking French natively, because this is how they do. Before exclamation mark, question marks, they put space. So if they write you hello, space, exclamation mark, it means they speak French, most probably. So cultural context matters. It's in us, it's in your users, it's in you, and you need to make sure it matches, because it's the culture and our mind imagination about the systems we make, how people will use them. Another example, coming from the guy I'm working with, from David, he, for one of his clients, made another application. It was something based on Drupal or Django, something like that. And in typical simple web application, let's say a simple store, so people need to log in to get access to this application. The form is pretty obvious. You know, there's you know this very well. There's username, there's password, login, register. Maybe remember me. Maybe I forgot my password. Something typical. And let's say this is a ugly IT guy. This is a cheeky lady using this system, and he sent this password not by snail mail, but by email to the lady. He handled the password to the lady, so she could just log in and test the application and say if everything's okay. And after a few days of email ping pong going this way and that way, it doesn't work, yes it does, no it doesn't, yes it does, works for me but doesn't work here, he was quite frustrated. He was like considering to give up with everything, screw that and go to Bieszczady, basically. So in an act of despair, he wanted to see what the lady sees, so he went for screen sharing. And during the screen sharing session, he asked the lady to log into the platform. And she was logging character by character, like typing the password. And he asked her, okay, but why don't you simply copy and paste the password? This is what we all do, right? And she said that, I can't, because I can't select the dot. I beg your pardon, which dot? The dot, the last character of the password. But there's no dot in the password. Yes, it is, I can see it. Well, I didn't send you a dot. I don't see it in a screen share, but I see the dot on my screen, and I can't select it. What do you think? What happened? Sorry? Exactly, you want jellies. This is what happened. A little dot left by a fly on the screen in the very precise place when the password ended in the Outlook for the lady. And curious thing is that if in every other situation, she knew that this is a dot, a little bit of dirt left by a fly. But when she wanted to select the password, her brain recognized it as a part of the password. You see, so sometimes context is really freaked up beyond any recognition. Sometimes you really need to make a long shot to get the right context to find out what's not working properly. Okay, so we're getting into the IT world dilemmas. Which sorting algorithm is the best or the fastest? It depends, okay. It depends on what? Kind of data, for example, yeah? Very, very good guess. Yes, I hear very good answers, but very often I hear that it's quicksort, that quicksort is the best. So let me show you a little video I found on YouTube. It works like this. We'll go a little bit forward. See quicksort 1, reversed, quicksort 1, again quicksort 1. So, as you can see, there are two problems with this video. First is the music. Another one is the data being sorted. I mean, how often do you sort evenly distributed data in your application? Exact 100 numbers from 0 to 99. It's purely artificial. It doesn't make much sense. That's why such examples are considered by me as harmful. So, you can check out my branch on a GitHub of this program where I decided to show it in a bit different way. So I was sorting data which were just different. In this very same program, I just changed the data sample, and turns out that insert sort or bubble sort is faster. And we can go through one of such examples here. Let's imagine we have to sort such numbers. These are Roman numbers: 1, 4, 2, and 3. If you didn't happen to have that at school, somehow. This is the representation in the numbers we use every day. And a curious thing is, if you need to sort them in ascending order, you have 5 comparisons in bubble sort, and you have 6 comparisons in quick sort. So if the process of comparison is taking very long, let's say you can't cache these numbers. Every time you need to read the string, parse it, and make a representation in Arabic digits or numbers. The process of comparing two entries, two pieces of data, gets longer and longer. That's why for such a probe, bubble sort might be faster than quick sort. You can check it out at the visual algo, if you will. So what are the factors of sorting algorithm? Initial order of the data. Keeping initial order. If you have 2 A's, whether the first A will still be the first one after being sorted or not. The data size. Cost of comparison, as I show you. Cost of swapping 2 elements in a collection. Cost of inserting an element. It differs from an array where you have to shift the next numbers, or where it's linked list, so we can just put it in. There's cost of index-based access. There is a cost of additional memory if you happen to have like an accumulator in merge sort or heap sort. And there are many other factors for sorting. So there is the best algorithm, the best sorting algorithm if the data is unknown. If you don't know your data, you can't say that the algorithm is the best or the fastest. You need to know what kind of data you're going to sort to tell which sorting algorithm or which algorithm is the best, basically. The data is your context. Slow application. An example of slow application. When you have a slow application, very often people say that it's because of the DB, that DB is slow. Like there's single DB or something, there's a problem. For those of you who are young or not coming from Poland, a few years ago we had a kind of a Polish Facebook. It was called Nasza Klasa, our class, and it was initiated by 4 guys from Wrocław, 3 developers and 1 graphic designer. And what happened, on average Sunday, when it became extremely popular, I mean, it became so popular that it exceeded the expectations of the creators. The app was very, very slow. I mean, after eating chicken soup Sunday afternoon and watching Family Feud, everyone wanted to log in to Nasza Klasa, and the app didn't perform. You couldn't even log in, not to mention to see the list of your polls or messages or something. So some people say that it was because of the lack of indexes, that these 4 guys hired a database admin. The database admin came and as a superhero and added indexes. So and then the application was performing good enough so you could log in on Sunday afternoon after your chicken soup and Family Feud. Well, is it really the case? I mean, indexes are like perceived as an aspect of thing or a mean of making your application or your database faster. Remember that indexes are used only in workflows. If you don't have workflows in your query, they're not going to be used. They are built and balanced using like black-red trees or other trees during inserts. Well, not only, but let's say inserts. And make sense for fairly distributed values. Like if you have a country code of a shipping address, and 95% of your shipments comes to one country, let's say Poland PL or German D, and you have index on that field, it doesn't make much sense to index like 95% of the data being exactly the same value. And the data needs to be like easy to index. It has to be a like integer or date or something. Like varchar 4,000 characters is not necessarily good for indexing, right? You can't just index everything. So if you happen to have an application which adds like the whole month adds invoices, invoice after invoice after invoice, and you have like an index or something in this invoices table, and then the index is being rebuilt with each insert query. And then at the end of the month, you just run one query to get a report for your boss or CFO or someone, which means that you're wasting time building and balancing index with every query you run through the month, and then at the end of the month, you're running just one single query to use that index. So it's not necessarily making your application perform better in general scope. So you need to take care when just putting indexes. Indexes are not free lunch. They don't come for free. They have a cost of building the index, balancing it. And ingredients of your lunch and of your index and the way you consume it also matter. The way you process your data is your context. Not only your data, but also the way you process the data. Next example, let's say you have to print a sorted list. How can you print sorted list? Ideas, please. I have more jellies. No ideas. Everyone's so afraid. Yeah, we're in the basement. I have a soul. Okay, you have to print sorted list of children's names. In typical 3-tier web application, how would you do that? You have typical 3-tier web application, database, application servers, clients like in browsers or mobile apps, and you need to print children's names. How would you do that? Where would you do that? It depends. Very good answer. Let's say you have 3 names to sort, like Anna, Adam, Anna, Hubert, and this is a mobile app. It's going to display. Let's say you're a parent, and this is like locating your children. You're a father, you're a mother, and you're locating your children. And this is what the app is going to do. And you like to see the children in alphabetical order, let's say. So how can you print that? Yep, exactly. Who said that? Was that you? Okay, you want jellies. So I'm sorry, I'm not very good at graphics. So this is my 3-tier web architecture, right? This is the database, application servers, laptops, and this is a BlackBerry. So remember, you don't do that here in the database. You don't do that here in the application servers. You just sort it here, let's say in JavaScript, because your goal or the requirement was to print the sorted list. It wasn't to send sorted list from the database to the server. It wasn't to send sorted list in JSON from the app server to the client. Your requirement was to print sorted list in here, so we can sort it just before printing. And it's cheap. Actually, it's free for you because it's not your CPU. So you don't have to pay for more CPU ticks. So your boss will be most probably happier because he can save for a new Porsche, right? Because it's not your energy, it's not your cost. It's these folks' responsibility to print this, to sort this data before printing. and you satisfy the requirement. So order by is not for free. I think this comes from academia. From many students, when they have a requirement to sort something, they instantly like sort, use order by, because this is the way they know for sorting data. And sometimes you simply shouldn't use that, because it will work, but it's not the best way of sorting data. So order by is not for free, and any other data processing is also not for free. Every processing of data costs you something, simply. I had a discussion once with a guy who tried to tell me that if you run a query, let's say against MySQL, so the query without order by will not be faster, or at least performing as good as a query with order by. Because I say that if you add order by to SQL statement and you see the execution plan, there's always a stage of sorting the data. And sometimes the data is sorted in memory, sometimes it's sorted on the disk. If the table is huge and the database engine needs to create a temporary table on disk, there's a lot of tuning involved. But certainly there has to be done something to sort the data by the database. The purpose of data processing is your context. If you need to have sorted data in the application server, you may sort it in the application server. But if you don't need it to be sorted there, you can sort it in the client if it's just for printing. Interrupt in Java is broken. Every 2 or 3 years when I go to a conference, there's a talk about threading in Java. This happens to DevOps this year as well. And very often I hear during these talks or during various talks amongst developers that interrupt in Java is broken. That it doesn't stop the thread instantly, that you have to set interrupt flag or rethrow something, blah, 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 yada, yada, yada. Interrupt in Java is broken. I have heard it too many times, I think. Now, guys, I hate PowerPoint karaoke. I hate reading walls of text, but I believe that in this very context, it makes sense. So let me read it loud. An interrupt is an indication to a thread that it's an indication. It should stop what it is doing and do something else. It's up to the programmer to decide exactly how a thread responds to an interrupt. But it is very common for the thread to terminate. This is the usage emphasized in this lesson. So it is very common, let's say 99% of the cases, to stop the thread or kill the thread when you interrupt it, but it's not always the case. So interrupt is just an indication to a thread that it should stop sleeping, waiting, computing something, waiting for a response. It should stop its activity and maybe start doing something else. If you have a thread per request, you can't just kill your thread, because maybe they're going to be reused. If you have 10 milliseconds to handle every request, because there's, let's say, an ads auction or something, you can't just kill and spawn new threads. Threads are meant like lightweight processes, but still they're not for free. So maybe you'd like to reuse them. So maybe you'd like to implement interrupt, let's say, not only for killing. And do you know what I like the most about this snippet of text? The URL it's available at. It has essential in name. Really, this is an essential knowledge. That interrupt is used not only for killing threads. In other words, interrupt means
may I have your attention, please? May I have your attention, please? Will the real Slim Shady please stand up? I repeat, will the real Slim Shady please stand up? We're gonna have a problem here.
We don't have a problem here. In other words, interrupt means, may I have your attention, please? It doesn't mean, hey, stop. It doesn't mean, hey, kill yourself. It means, may I have your attention, please? Stop doing what you're doing, because I'd like to have your attention, Mr. Thread. This is the contract of interrupt. So, thread interrupt is not dropped-in replacement for thread stop, which is deprecated now, or thread destroy, which wasn't even implemented. It got deprecated before it got implemented. You can go to my presentation here, and it's a link, so you can read a very nice article why it's impossible to create like a thread stop or thread destroy method in a generic way. Too long did you read? It's about logs, monitors, unwinding stack, and so on. It's not possible to create generic method to stop every possible thread in threading model. This is simply science, and there's an explanation, detailed explanation why. The last example from IT world, optimization. Say there's a sale on it's Thursday, it's Black Thursday, isn't it? And it's Monday, and your boss comes and says, oops, we have a problem. This is, let's say, this is our CPU chart, or this is our router chart, and we have a problem. Which color predominates this chart? Waiting for the answers. Black, yep, exactly. Who said black first? Catch! Almost did that, sorry. Yep, the problem here, people start focusing that there's not enough green, that maybe there's coincidence or maybe not between this drop here and this spike here, but people like kind of forget that the black is here and it predominates, that this is the, let's say the biggest area occupied by color. And maybe if you have just 2 days to optimize this optimization, and Thanksgiving in between, maybe for a very short term you're not going to investigate why there's so much red, why the red seems to like go high here when the green goes down here. Maybe what you like to do is this. Just stretch it. Get rid of the black color as much as you can for the short term. Because many times people say that, like you have a discussion with network admins, and they tell you, oh, you are at 60% of our router utilization. You can still go for this 40%. You're still safe. You're below the threshold, the maximum we have. And then you ask them, okay, so how can I generate 100% traffic? And they try to do that, and apparently they can't, because this 100% was calculated for so-called jumbo threads, for example. Jumbo frames, very big frames, and your application is just sending very short snippets of data, like, I don't know, heartbeat or something, like 3 bytes, 4 bytes, not 8 kilos. So you can't get with such small traffic 100%, for example. So you always need to make sure that what you define your context is not too narrow, that you don't only look at these 2 colors, that you see the whole aspect of things, also the missing areas. The last part, simple way of finding and determining context. You can just go why, and why, and why, and why, and why, and why. Does it ring a bell? It's a 5 why principle. So if there is a situation happening, if there is an incident, a problem, whatever, when you're looking for a cause, you just don't stop with the first why. You just go deeper, We need to go deeper. An example of that, let's say there's a factory, there's a plant, and you're the boss, and you're going like in here, and you see some oil spilled on the floor. And you can just go, hey, Johnny, clean this up. And Johnny can come and clean this up. But it may not solve the problem. You may not know what is the context. You may not find the cause of this oil. So you may ask him, hey, Johnny, why is the oil on the floor? And Johnny may tell you, hey, boss, because the pipe's leaking. Okay, Johnny, but why is the pipe leaking? I don't know, I'll find out. 2 hours later, Johnny comes to you and says, I know, it's because of the Bobby. But why Bobby? Because Bobby is putting too much load on the ramp, on the loading platform. Instead of, like, let's say, 1 item, he puts 3. So when he tries to lift it, there's too much pressure, too much oil pressure, and the pipe, has a weak point there, so it's leaking there. So you, this way, reveal the actual problem. It's not the oil on the floor. It's not the leaking hose or pipe. It's Bobby not caring about health and safety, putting too much load on the platform. This is the actual problem. This is actual cause of, problems with pressure, leaks, that someone may slip and broke a leg or something. Another way, a bit more advanced, I like the term Fishikawa. It's one of the names of this technique, but it's actually about Ishikawa fishbone diagrams. It was invented in Japan by Mr. Ishikawa. And you know, Japan, islands, oceans, so like they think about everything in terms of sea, ocean, and fish. That's why it's fishbone diagram, I believe. I think if it was invented here, we would call it a Christmas tree diagram. Let me show you why. The other name is cause and effect diagram, and it looks like this. Imagine you have a fish head here, this is the spine, and these are just the bones. And if you tilt your head on your shoulder, it starts looking like a Christmas tree, a little bit. We are missing more branches here, and if you imagine these are branches, it starts looking like a Christmas tree, like a spruce. And again, this is the main defect. This is the main problem, and you are about to discover the causes. So you divide it into sub-causes like machines, methods, environment, measurements, materials, and personal. And for each, let's say, sub-defect, you find more and more sub-defects. You go deeper, up to the level you find satisfying. So it's not a simple linear 5 times y, it's like spreading across in all directions you find important. This also works very well for finding requirements or determining the context. Okay, we need this button to be big and red, but why do you need it to be big and red? Because this and this and that, and you have 3 bones. And you can get deeper into these bones, and then you can find out the actual problem the client has. And maybe it shouldn't be solved with a big red button. Maybe it shouldn't be even solved in your application. Maybe it shouldn't be even solved at all. Maybe it should be eliminated somehow. If you want more, like inheritance is good, composition is bad, Java is slow, transactions are a must, or Windows is an operating system, you can check out Wrocław Java User Group YouTube channel if you speak Polish. There will be a video soon because I could give much longer talk at Wrocław Java User Group about these subjects, about these mantras, which are sometimes false. And the takeaway for this presentation is not this. So people like ask me sometimes, so does it mean I should always search for a context now? Does it mean that on Monday when I come back to my office I should start talking to my colleagues, hey, we need to revisit all sorting algorithms we use because the fella thought that we need to check the sorting algorithm. We need to get rid of all the indexes. This is not what I'm trying to tell you. If it's okay as it is today with your sorting, just leave it as it is. Don't worry. The sorting is probably okay. But if somebody asks you which sorting algorithm is the best, they just don't shoot loud quick sort or merge sort. Ask about the context. Just remember the context exists, and the obvious one might not be the best. Be aware, folks, because it depends. Questions, please. Oh, sorry, before questions. If you like these presentations, please rate it. If you didn't like this presentation, rate it too, but then provide some feedback, please. And please, please, please just do it not for this presentation, but for any presentation you attend at any conference. Such a feedback, positive or negative, really matters a lot to every speaker. So please spend a minute giving your feedback. Thank you. Any questions? I still have 1 jellies left for a good question. If there are none, just enjoy a coffee. Thanks.